I realize that we are still going over pointers and that some of what you need to do for the lab is for this week. So this is a 2-week lab. And what I realized is that because we're going over pointers and we haven't quite finished them, it seemed a little bit harsh to make you try to finish it all by Thursday morning. So I pushed the first due date for this lab back till Saturday morning. So that gives you a couple more days to work on the first part of it. I did not push back the final thing because it always was a 2-week lab. But today we're going to finish up some of the pointer stuff that you may need in order to finish the first part of the lab on Saturday, really Friday night. Okay, so I pushed that back by 2 days. The other thing is we're going to have a vote about this. You'll see that in the lecture notes we have a midterm that comes up incredibly quickly, 3 weeks and right before spring break. And I realize a lot of you may have exams during that time. So the vote that we're going to have is whether you want to have the second midterm still on the original date, which is Thursday, March 10th, which is right before spring break, or whether you would rather have it on Thursday, March 24th, which is the Thursday after spring break. So the advantage, obviously, if we do it before spring break, is you get it out of the way. The advantage to after spring break is maybe it's not as rushed the week after spring break, and it gives you more time to study. So I'm going to hold that vote right now. So how many wish for it to stay on the current day of March 10th? Okay, raise them high so I can count. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And how many would rather have it on the 24th? Okay. It will be on the 24th. I'm sorry. But it happens to probably be better to have it on the 24th because it divides up the material more equally by weeks as well. So we will have the midterm on Thursday, March 24th. Okay, so midterm, I will change that in the notes.
Does that also change the programming portions day? Would be the day before instead of the 9th?
Yes, so it will also change, thank you, Ashley. It will change, the programming portion will now be Wednesday, March 23rd. I will change both of those, but just make a note of that. I will also post to Piazza. It will cover a bit more, let's see, it will then cover sets and maps, and because, let's see, I believe at that point you will have had a lab due. Let me make sure. You have a lab due on the 24th. You have the Kino, so you'll be responsible for everything up through the Kino lab. Okay, so you'll be responsible through everything up through that. So probably you will be responsible for the coding portion. You will be responsible for everything up through sets and maps. Okay, so still be the same material on the exam. You'll just have a little more time to study for it. Okay. So what I'm going to do is first just go over a couple of the coding questions from the exam, go over their solutions, and then we'll do a little more with pointers. Okay. So, the printf one, the big thing there were two things. One is knowing how to print out a floating point number using 6.1f, and the other one was knowing how to do padding of your digits. And this is important for you to remember. That's why I tested you on it. I only deducted 1 point for not knowing it, but you need to know that if you want to pad with something other than spaces, then you put the padding character in front of the width specifier. So many of you were saying if seconds less than 10, and there's no reason to write a different printf statement for the two cases. Okay, you just write a single printf statement, and this handles both the case where seconds is less than 10 and where it's greater than or equal to 10. If it's less than 10, it will pad the digit with a 0. If it's greater than 10, it will naturally print it in a field 2 characters wide. The other issue I had is many of you didn't want to convert the minutes and seconds to a floating point number. So you would try to do things like, say, %4d, point, %1, or %d, stuff like that. And that doesn't work out too well. So for example, I would see %4d minutes and seconds, except that would print as, for example, 36.41 if it was 41 seconds, and that's not right. It was supposed to be 41 divided by 60. So the thing to do was to actually print it by converting it to a floating point number and then saying minutes plus seconds divided by 60. Now what many of you forgot, and hopefully it was just because it was the pressure of the test, is that this by itself does integer division. So I saw a lot of stuff where people would write double time is equal to minutes plus seconds divided by 60. And you seem to have forgotten from 102 that this doesn't work. Okay, you were thinking that somehow the compiler would magically know that time was a double and therefore it would do floating point arithmetic here, but it doesn't. It just looks at the right hand or at the two operands, and it looks at their types, and they're both integers. So it does integer division, which means what is this result always? Because seconds is less than 60. It's always equal to 0. So you had to find some way to convert this to floating point arithmetic. Doing a cast works. Some of you divide it by 60.0. That works, but you had to find a way to cast it. Now, if that's the only thing you did wrong, I still gave you full credit. But if you combined it with other mistakes, I considered it like a half-point deduction. So if you missed nothing else, you still got a perfect score. But if you missed something else, then it was half plus whatever else you missed. So those were the two big misses there. Okay, on the type def, almost all of you got type def right. In fact, it turned out that the majority of you who didn't get type def right simply didn't press the grade this part button, and you would have gotten it right if you simply pressed it. By the way, I have to change this. This should actually say vector of int. There's an HTML bug here in the actual code. it says %int. Let me change that now before I forget. Okay, so you can see here in the source it does say vector int, but does anyone know why, who knows HTML, know why this ends up showing up as just vector right here without the int? Pardon? Yep, it thinks it's an HTML tag and it has no idea how to interpret the int tag. So I have to replace it with entity codes. Now it should show up properly. There we go. So most of you got that, no trouble. The string one, most of you were doing good with the finds, except that I saw a lot of things that were something like int, say, comma 1 equals line dot find, comma. And then I would see comma 2 equals line dot find, comma. And that's just going to give the same result. In order to get comma 2, you have to start 1 past the location of the first comma. So once you know where the first comma starts, your second call to find should tell find to pick up the search at start plus 1. Otherwise, if you do it like this, it will simply find the first comma again because it will start at the beginning. And then the second thing you did, which I found interesting because it means that the C++ developers shouldn't have done it this way, is that if comma 1 was a pointer to your first comma and comma 2 was the integer index of the second one, many of you were writing substring comma 1 comma 2, except that substring doesn't go from start to end. It's the second argument has to be the length. So it had to be comma 2 minus comma 1 minus 1. So you have to remember that it doesn't go from start to end. It's start and then the number of characters you want to extract. Okay, and some of you also forgot the plus 1. If you started it at start, then you would get the comma. You really needed to have start plus 1, but not sure I even took off points for that because I knew it was kind of, you were under time pressure. I took off 1 point for saying comma 1 comma 2 rather than comma 2 minus comma 1 minus 1. Okay, so those were the big issues there. Okay. Command line was asking you to print out all of the arguments that weren't integers. And this was the first one that was a little mystifying to me because almost every single lab you were forced to use iString streams to check whether something was an integer or not. And yet I would wager that half of you did not include string streams in this solution. Okay, this is an idiom that you need to be familiar with, which is the idiom for how to convert. So you need to be familiar with the idiom of how to convert a string to a number. Okay, and we've been, every single one of your labs, I think, except maybe the first one, had this idiom of using a string stream. But like I said, about half of you didn't use a string stream, so I'm not sure what was up with that. It certainly should have been on your cheat sheet. So at any rate, it was the one time where you had to write a complete program, and it simply involved iterating through the command line arguments. You needed to declare a string stream buffer, and you needed to clear it each time, and then stuff the argument into the buffer. And if you couldn't convert it, then you simply printed out the argument. So it wasn't meant to be a complicated program. Some of you, I didn't take off points. Some of you who got it right, instead of saying cout argv, created still one where you said, instead of this, what you said was buffer.clear, and then you had string value, and then you said buffer into value, and then you said cout value, which worked, but it was more complicated than it had to be because you didn't need the buffer at this point. You could have just printed out the command line argument. So you made life harder for yourself than you needed to. I didn't take off points, but the simpler solution was to simply print out the command line argument. But the key point here that I wanted you all to get was you use string streams to convert integers, or I'm sorry, strings to integers, and you use string streams to check if the conversion worked, and if not, you do something about it. Okay? So questions about this one? Okay? So question 5 was actually reprising a problem we asked many of you in CS 102. And I knew from 102 that many of you had had difficulty with reading lines into a vector when the input could be exhausted before the number of lines you were supposed to read. So for example, if this was your file, then if n was 3, you would just read the first 3 lines from the file. But if n was 10, then you would just read the number of lines in the file and return. Okay, so there were 2 big problems here. One, many of you still were unsure of how to open a file. Again, that's something that should be on your cheat sheet, how to open a file. Okay, because we'd done that a lot in, not a lot, but we had done it in lab. So many of you still tried to read from CN, or the other thing I saw a lot of was writing something that looked like vector string, what was it, get lines. And you'd have string file name. And int n. And then what I would see somewhere is simply get line, file name, line. And that doesn't work because file name is a string, it's not a file. Okay, so this doesn't work. You have to actually declare an IF stream, say file, and then you have to open it. and then you say get line file. So that was part of this problem, was seeing whether you could open a file for input and read from a file. Many of you either, as I said get line file name, or else tried to read from CN, which resulted in a 3 or 4 point deduction because, as I said, you were supposed to read from a file. Okay, so the correct thing to do is it's missing a statement. The question is why? Huh. This was actually copied, I thought. So this should have infile.open file name. Yes, missing a line. So infile.open. Then there's two things. First of all, your loop should continue while you have not yet read the number of lines. And the second condition is while there's another line in the file. So your loop should continue reading as long as you have not yet read the requisite number of lines and you still have lines left to read. So then you push back and you increment I and you return lines. Now some of you were doing lines of I equal line, but that's not the way you add strings or items to a vector. You use pushback to add items to a vector. Some of you were resizing at the very beginning. You were saying lines dot resize num lines, but you don't know that there's going to be that many lines in the file. And in addition, most of you who said lines.resize were still saying lines.pushback. And what that does is it actually, let's say numLines was 3, it creates 3 empty entries, and then when you start saying pushback, it puts the first line actually here, so you actually ended up with an array that was twice as big as you meant it to be. So you definitely did not want to use resize here. So the big problem I saw here is just assuming that there was enough input. So you would say I less than n I plus plus get line in file line, and then you would say lines.pushback. But this assumes, you were assuming then that the file had enough lines in it. What do you think happens if it doesn't have enough lines in it? It pushes back the last one constantly. So if there's 6 lines in the file, you'll get 10 lines, except the last line will be repeated 5 times. Because it will go through the loop each time. Get line will fail, it will leave the old value in line, and you will push back whatever was the last line in the file. Now, you could write the loop this way, but what would you have to do to get out of here? Right, so you could do this as long as you said if get line pushback, else break. So it was fine if you wrote it this way as long as you put an if statement in front of your get line and you broke out of the loop if the get line failed. That would handle the case where the input was exhausted early. Okay, this happens fairly frequently in computers or in programs. So this is another idiom you need to commit to memory. Okay? If you didn't do it in 102, then please try to do it now. So what I was doing in this exam was actually trying to test you on certain idioms that you really need to memorize because they happen again and again in your CS career. Okay, and then the last one, amazingly, I thought this was the hardest problem, and it is the one that had the highest success rate other than for type def. So I was really pleased. I thought this was the hardest problem, yet most of you got it with the dot product. So the idea is that you have a column and a row, and you're simply doing a pairwise product of the elements and then summing them together, which means that you need to have a loop that runs through this row. So the easiest way to do it is to simply write a loop that runs through this particular row. And then for each element in this row, it finds the corresponding element in the column. Okay, so if we here, let's just show you the solution. And I even forgot to put a no, I didn't show, so I'm going to put an int amp. It again eats ampersands. Okay, I'll fix the rest later. Unfortunately, it also eats ampersands. Okay, so I'll come back to this. But basically, you ran through the appropriate rows. So in this case, you're going let's say this is row. Let's say row is 0 and column is 2. So this, the I, is tracking through each element of the row. So that's what this is doing. Over here, this is the column. So you're starting with the first element in the column, which is 0. Then on the second one, it's -7, which is at location row 1. Then row 2. The last one is row 3. So whereas here, I is picking out the column. Over here, I is picking out the row. So all you needed was a single for loop for this particular problem. Okay, and most of you got it. One thing that most of you did not do and got a point deducted for was passing your objects by reference. I even tried to help you in the instructions. Whoops. Remember to pass all object parameters by reference, but most of you didn't. Okay, so it's just something you have to try to get into your minds, that when you pass strings or any kind of object vectors, you should pass them by reference, because if you don't, it slows down your program. So I took off a point. I didn't repeatedly take off a point, because that would be cruel, but I did take off a point, usually on the vector problem, because that's one of the first ones I graded. Okay, so I guess the bottom line here is, when we've been emphasizing things in the labs or lecture like string streams, you really need to have that stuff on your cheat sheet. And things like vectors. A lot of you weren't using pushback. Okay, so there's things that you just really need to have on your cheat sheet. I think it helps to have code. Like if you just taken an example code from lecture about input, like from early in the lecture we had one where we summed up numbers and discarded bad input, or if you took something from the Moonglow lab and put that into your cheat sheet, you would have had something that showed you the idiom for converting strings to integers. Now, obviously, it's not exactly the right code, but you would have been able to modify it. So, in general, I think on your cheat sheets, it would be good if you put examples of code. Okay? Also, as I told one student, you should always be careful when I ask a question in class and everyone looks at me blankly. So at one point, I asked you for printf in class what this particular format specifier did, and I got a lot of blank stares and no one answered. So I went ahead and told you what it did, but I also made a mental note that that was going to go on the exam because it's something that you need to remember, and you all obviously had not done it. So I'm just telling you hints that you can use with at least me for studying for an exam. Or if I ask a question in class and no one knows the answer to it, there's a good chance that that concept could end up on the exam, because if I care enough to ask a question about it, I want you to know it. Okay? So it means if I ask you a question in class and none of you answer it, there's a good chance you'll get a second bite at the apple on a midterm. Okay, now, a lot of you I know didn't do so well. The median was 33 out of 50 on the coding question. I curve, so please don't panic. Okay? I don't curve individual exams, but I do curve the final grades for the course. So don't panic if you got like a 25. If you got less than a 25, there's issues, and you should be a bit concerned. Okay, but over 25 is not yet. Now, say 25 to 30 probably is getting you a C, but it's not horrible. 30 to 40 is probably a B, 40 to 50 is probably an A, somewhere in there. Okay, maybe not exact. And we have to look at the whole exam, and like I say, I don't curve until the final. But the point is, don't panic about not doing well on the coding. On the other hand, I wasn't trying to trick you on this, okay? I was asking you questions that I thought were fairly straightforward, and I thought if you had prepared a good cheat sheet, you should have been in position to answer the questions, okay? So I guess all I can say is, A, maybe go back and check your cheat sheets. I don't believe Ben collected them, did he? Yeah, so go back and check your cheat sheets. And the other thing is, just remember, if we've been doing things a lot in labs and also showing you examples of code in class, there's a good chance you're going to have it on the exam in a coding question. So including code snippets, I think, really is the best thing you can do for the coding portion. Now, a printf statement's the one exception. You really probably did have to put down what the format specifiers are. Okay. The other thing I will say is, I know it's easy to get in the habit of Googling a lot of stuff because everything is online, and that's fine. But in practice, if you Google everything, you're not going to be a very fast programmer. And when you get into the real world, you will be compensated on your speed. So I know that it's very easy to not memorize stuff and to try to Google stuff, but that will come back to haunt you on an exam, and it will come back to haunt you in the real world. Because someone who is able to memorize stuff and produce it from memory is going to produce code faster than someone who has to Google everything. And bosses will notice. Okay? So I know it's painful to memorize, and the good news is the more you do this stuff, the more it will naturally memorize for you. But at any rate, those are, I guess, are some words of wisdom. So I'll go over the paper version on Thursday when you have it in front of you. And I'm going to transition now to talking again about pointers so we can finish that section up and move on to linked structures on Thursday. So you may remember last time that we started into pointers, and the way you declare a pointer variable is with star p. So that declares a pointer variable. Remember, a pointer variable stores a memory address. So if we have A and B, and then we have these memory addresses. And I say P equals ampersand A. The ampersand says, give me the address of A. So the ampersand is called the address of operator. And how did we, if we wanted to use P to assign the value 10 to A, how would we do that? If I want to assign 10 to A using P, what should I put on the left-hand side? Star P. So this is called the dereferencing operator. So when I say star P equals 10, I'm saying store 10 in the variable that P points to, which is A. And similarly, if I say B is equal to star P plus 20, I'm saying find the contents or the value of the variable to which P points and add 20 to it. So in this case, since I just assigned 10 to A, B is going to get 30 because P points to A. The value of A is 10. When I add 20 to it, I get 30. Okay, so that's a quick recap. Then we introduce this idea of what I call unnamed variables, where you could create objects or things off of what I called the heap. So remember, I introduced this idea. You already know about the stack, where we put the local variables and parameters for functions. But then there's also something called the heap. So the stack kind of goes up and the heap comes down. So this is the memory allocated to your program. Every program is allocated memory. So the heap goes down, and it's where we allocate memory for new. So the heap equals the place where the new operator allocates objects. So in this case, maybe the heap starts at 0x5000. So P would end up, in this case, let's say P is in foo, P would end up with 0x5000. So this I tend to call an unnamed variable. It exists right here in memory, but it has no name. I can still assign it a value. If I say star P equals 30, it gets the value 30 because P points to it, and it gets the value 30. Okay. And let's say I have this situation. If I do this, what happens effectively is we start and we have P and we have the heap. So originally P might get, say, 0x5000. And when I assign P equals 10, or star P equals 10, it assigns 10 to there. Now when I say P equals new int right here, it assigns it a new value. Something like 0x4, probably FFC, because we're now going down, and that subtracts 4 from hex 5000. And this state, so this now gives P 0x4FFC, and now this statement right here assigns 20 to it. I gave you a term for what happens to this piece of memory last time. This memory no longer has a pointer to it. It can no longer be accessed by anything in the program because it's an unnamed variable. The only access I had to it was through P, and now that P points to a different memory location, the memory location that I've circled in red can no longer be referenced. What did I call this situation? A memory leak. So a memory leak occurs. So a memory leak is a piece of what I'll call heap allocated memory that was not deallocated that has, I'll call it piece of memory, heap allocated memory that has no pointer to it. Because that's what it is. It has no pointer to it. So it's lost. So you have to get into the habit with pointers of managing your memory. Now, there won't be a lot of such management in this course. However, we do introduce you to it. Before you call P equals new int here, you really need to call delete P first. What delete does is it returns this piece of memory to the heap, gives it back so that it can be given back out. So basically, when you're about to lose the last pointer to a piece of heap allocated memory, it's important to first delete that memory location so that it's returned to the heap. This won't actually, the failure to do so typically will not crash your program, because just because there's a piece of memory that can't be referenced, it doesn't affect the correctness of your program. However, what do you think happens if the program runs for days like an Amazon server? What do you think eventually happens? It runs out of memory. So in the real world, where you have servers that have to run days at a time, memory leaks become dangerous because eventually the server will freeze when it runs out of memory. So in fact, in the real world, memory management is very important because memory leaks can eventually cause a program to run out of memory. Now, you will be writing such small programs in your career here at Tennessee that it's unlikely that a memory leak is going to bring you down. But you do need to try to get in the habit of cleaning up your memory when you no longer need it. Just like with toys. When you were kids, your parents weren't too happy when you took a toy and off the shelf played with it and then didn't put the toy back on the shelf again when you were done, right? You used to get nagged at by your parents to clean up your toys. Well, we will nag you to clean up your memory. It's the same idea. If you take memory from the heap and you're done using it, you should return it to the heap. Okay? Yes, Jaja.
I'm just wondering, can we assign a printer with the address, like the address we know?
Yes. So you want to say, can you say something like P equals 0x1000?
Yeah.
You could. Never do it. Because you'll learn this later, there's never an absolute program, absolute address in a program. So each time that a program is loaded in memory, it may be put in a different location in memory. So like you have maybe 8 gigabytes on that laptop, and it's never loaded, it's not always loaded in the same place in memory because you have multiple programs that are running. So on one situation, your memory you might be loaded at, say, location 0x5000, and another time you might be put at, say, memory location 10,000. Okay, in both of those situations, 1000 is not even in your program.
But it's like inside of one program, like I want it once. Like in this program, if I have a memory leak at 0 times 5000, and I want to put the 0 times 5000 back to the pointer, can I do that? It will still be on there, right?
But then it would still be there. The problem is you can't ever hard code it. You would have to keep the 0x5000 in some variable. Because you don't know when you write the program and you execute new, you don't know it's 0x5000, right? So you'd have to still store that 0x5000 somewhere, which means you couldn't have a memory leak because you still had a pointer to it. As long as you've stored that 0x5000 somewhere, you still have one pointer to it. Okay? So, but the answer to your original question is you can do this, and it's incredibly dangerous, and it will almost always cause your program to segfault because it almost always will point to some location that's not actually in your program. It's not a relative offset. It's an absolute pointer to somewhere in memory. Okay. So here's a common mistake, which is this one. What do you think happens when you execute this statement? Let's try it so that you can see the glorious beginning of your new career, because this will happen to you a lot in the rest of your career. And it's unfortunate, but it is what it is, as they say. I do. Oh yes, I/O Steam. Thank you. Wow, love programming in front of people. Okay, so there it is. What is the problem with P, by the way? You should at least know there's a problem. I never initialized it to anything. Okay, so segmentation fault core dumped. Your new best friend. Actually, your frenemy. Not even your frenemy. It is your enemy. Because these things are hard to track down. What it means is that you tried to do what Jaja in effect did, which is access a piece of memory that you're not entitled to access, such as in the operating system. So every program is given a piece of memory, and you're not allowed to go poking around in other people's programs. So in general, let's see what P was. So let's print out P. This is going to print the memory address that P points to. So, in fact, it pointed to memory location 0, and I can tell you for a fact that the operating system puts its code at starting at location 0. So, normally, if you don't initialize a pointer, it normally gets set to 0, although not always. 0 happens to be the operating system's code, so trying to access something in the operating system gets what's called a segmentation fault. Segmentation because you're accessing a segment of memory that you're not allowed to. Core dumped because the memories used to be called cores, and when the programs used to crash, they literally used to print out the contents of core memory, hence core dumped. But we don't do that anymore. It used to be a whole bunch of zeros and ones, and you had to pour through the zeros and ones to figure out what had happened. We have better tools like now for doing it. But at any rate, if you try to access an uninitialized pointer, you will probably get a segmentation fault. Okay? There is another problem that can come up called dangling pointers, which won't affect you as much in this course. So let's say, yes, Zach?
Yeah, you said that there was a type issue with that if you declare a type pointer, you have to be able to set a pointer to it. And I asked you, since 20 was a valid piece of memory, would it accept it? And you told me no. And then you said that it was because of the type.
So, yes. So here this is okay because star 20 says assign the value 20 to the memory location pointed to by P. So P points to an int. I dereferenced it. The problem is if I tried to say, when you asked me, you were trying to assign 20 to P. That's different. That's trying to now if I do it, invalid conversion from int to int star. Okay, so that's an important difference. So that's how it knows. The star is how it knows whether to assign to P or to the variable that P points to. Okay, other questions? Okay, so the dangling pointer problem is if you say int star P equals new int. Now you say int star Q equals P. So if we look at this situation, both P and Q now point to memory location 5000. Okay, so I say star P equals 10. Now I say delete P. Okay, so this returns 0x5000 to the heap. But the problem is Q still points here. That's called a dangling pointer. So a dangling pointer happens equals a pointer to a piece of memory that has been returned to the heap. So even though we just returned memory location 0x5000 to the heap, Q still points to it. Now, that's not going to be a problem as long as we don't try to say something like Q equals 20. It's going to become a problem if we execute this statement. Okay, you may wonder, well, why is that a problem? Well, let's take a look. Let's say before we say star Q equals 20, we have yet another variable. And we set R equal to be new int. What do you think R is most likely to get as its memory address? Good chance it's going to be given 0x5000 because that piece of memory was just returned to the heap, right? I deleted P, so I gave it back to the heap. So now when I say R equals new int, there's a good chance that R gets to point to it. Now I say Q equals 20. Actually, first of all, I say R, before I do that, I say R equals 10. Now I say Q equals 20. And now I say C out R. What prints out for R? 10 or 20? 20. What do you think the programmer thinks prints out for R? 10. They don't think that Q is pointing to this piece of memory. It's not supposed to be. So that's what dangling pointers. Dangling pointers are even worse than uninitialized memory. At least uninitialized memory will cause a pretty fast crash. Dangling pointers just corrupt memory. So we say that the problem with dangling pointers is that dangling pointers corrupt memory because they unexpectedly change memory that you don't expect to get changed. So you have to be very careful. Remember I said that if you don't deallocate a piece of memory, when the last pointer to it is lost, you'll get a memory leak. But if you're too zealous about reclaiming memory, you end up with dangling pointers, and you could corrupt memory. So this memory management is it's like balancing on a high wire. And it's why more modern languages have decided that it's a bad idea and have taken memory management out of the hands of programmers. So more modern languages like Python and Java don't allow you to do memory management because it's such an enormous source of bugs. I can pretty much guarantee you that in your C++ programming career, you will spend the majority of your debugging time on pointer errors. Okay? This is opening Pandora's box and letting out both the good and the bad. Pointers are considered very good, but they also can cause a lot of problems. So now that I've told you their problems, let's look at why they are so good. Yes?
Like on that, if you didn't have R and then after you deleted P, could you initialize Q after the fact? And would it remove the dangling pointer?
So if you, what do you mean? If I then said, so what do you want me to erase here?
Like before you had the R's and stuff, could you initialize P after that? I mean, initialize Q after that?
You mean say star Q equals 20?
No, like
No.
could you like bring it back essentially? Like
You could say Q equals new int.
Yeah, like could you do that after the fact?
You could do that, and that would work.
Okay.
But then if you said r equals new int, r would get a different integer location than q.
Okay.
So
then
you'd
that
be
would solve
okay.
it.
Yeah, that solved the problem. But you also no longer have a dangling pointer problem because you just redirected q to,
But that would fix the thing.
that would fix the dangling pointer. Yes. Again, dangling pointers aren't a problem unless you do something with them. Okay? They only become a problem when you try to do something with them. Okay. So I just do want to get to this one part of the lecture notes. So Dr. Planck did his usual wordplay and has Zark Muckerberg defining a lame new app called Basefook. So, and basically, what it's going to do is allow a person to give their name, their mood, a person that is their significant other, and a list of friends. And we're going to store that information for each person. So he first shows you what Facebook really is, which is a program running on what's called a server. And your various mobile devices or your laptop connects to this server, and it sends lines of information to the server, such as your name, your mood, your friend. And it also sends information back when you request information, such as where is my friend currently eating lunch, if they want to be that known. So a server program is simply a program that's running somewhere and taking input from your various smartphone device or mobile devices and sending information back. So what he's doing is saying, okay, we're going to write one of these mock server programs, except that you're not yet ready to know about how to communicate with mobile devices, which you do over a protocol called TCP/IP and through what's called a socket. But he's saying, don't worry about that. We're just going to write the program, and instead of using mobile devices, he's going to have a series of commands that he's going to enter at the command line. So you can add a new person, you can give them a mood, you can specify a relationship that a person is in, and it's not bidirectional. So if I say I'm in a relationship with X, that doesn't mean X is in a relationship with me. Okay, and he gives the example with Gone with the Wind at the end, where at the end, Scarlett O'Hara professes her undying love for Ashley, and Ashley basically throws a hissy fit and says he doesn't love her, he loves Melanie. So at the end, Scarlett is in a relationship with Ashley. Ashley still thinks he's in a relationship with the dead Melanie, and Rhett Butler is, as Jim says, pissed. So at any rate, the relationship is not necessarily two-directional or bidirectional. And then you can add friends, and again, friends may not be bidirectional. Okay, so we're setting up the program, and one of the first things you do when you set up a program is you figure out what are my data structures, because you have to figure out how to store your data. There's two basic data structures here. One is you need to store information about a person. So we're going to store that in a class, and I know we say that you make things protected, but in this case, we're just storing the person as a record, so we're making everything public. Make things simpler. So everyone has a name, everyone has a mood. This is a little bit new. So we point to the person that we have a relationship with. So instead of giving the name of the person that we have a relationship with, we actually point to the object. So this is a pointer, points to the object. The object that stores the name. of the person we are in a relationship with. Okay, and the same thing here. This vector is a vector of person pointers, so it's a vector of pointers to people that are our friends. Okay, and then the second data structure is going to be a hash table that is going to hold pointers to our person objects. So we will use the DJB hash function that we looked at last week to create basically hash names using DJB hash, and then we'll look up those people using their hash keys in a hash table. Okay, so our hash table is right here. It is a vector of p vectors, and p vector is a vector of pointers to people. So our hash table is a pointer. Our hash table is simply a vector of pointers to people, like this. Each one has some pointers to people. Okay, so actually I'll show you first the way it looks. So he creates some new people. So let's see how it looks before we look at code. New person, Scarlett O'Hara. So our four main protagonists in Gone with the Wind: Scarlett O'Hara, Rhett Butler, Ashley Wilkes, and Melanie Hamilton. For those of you who've never seen Gone with the Wind, basically Scarlett kind of loves both Ashley and Rhett. Ashley loves Melanie. Rhett kind of loves Scarlett off and on, but Scarlett is very mercurial, and let's just say that throughout Gone with the Wind, she expresses love for both Ashley and Rhett, never can make up her mind. So we have friends. So Scarlett O'Hara is friends with Melanie. Scarlett is also a friend with Ashley, although she'd kind of like to be in a relationship with him. And Melanie is a friend with Scarlett, which is really bad since your friend is stabbing you in the back, but so be it. And then Rhett's in a relationship with Scarlett. Bad news for Rhett. Scarlett, for much of the movie, is in a relationship with Rhett, although that's off and on. Melanie is in a relationship with, Ashley and Melanie are in a relationship. So Rhett is very amorous. For much of the movie, Scarlett is petulant and angry. Ashley truly is limpet and wimpy. Why you would want to be in a relationship with him, I don't know, but then again, I guess I am not Melanie or Ashley. He does have two suitors, so I guess it works. And Melanie is very pious. So, at any rate, if we were to draw this all up with our hash table, first of all, it turns out that using DJB hash, Scarlett O'Hara hashes to 7, Rhett Butler hashes to 8, and how nice, Ashley and Melanie both hash to location 8. So if we look, location 8 is the interesting one, has a pointer to Ashley and also has a pointer to Melanie. Okay, and then location 2, its vector points down here to Rhett, and location 7 points to Scarlett. So you can see Scarlett O'Hara has the mood petulant and angry. She is in a relationship with Rhett. So the red arrows are our relationship arrows, and Rhett, you can see, is in a relationship with Scarlett. So the in relationship fields point to the appropriate object. And then we see that the friends, they are a vector of pointers. So Scarlett points to both Melanie and to Ashley. Rhett doesn't have friends. And Melanie has a friend, points to Scarlett. So this is how the pointers all work. There's 3 different pointers at work here. The hash table has the blue pointers. The in relationship has the red pointers, and the friends are the green pointers. Now they all, in fact, are person pointers. Okay? So on a test, I could very well give you a scenario like this and ask you to map out all these pointers. Certainly it would be a good exercise. Okay, so he's written the different code for these things. So the first thing he did was he wrote the find code. And his find does double duty. It actually both returns a pointer to a person if it finds the person, and if it's asked to, it will add a person to the file. You may have noticed when you wrote your hash tables in Lab 4, your code for find and add was very similar, right? So in this case, he combined the code and just added a flag to indicate whether he was adding a person. So he's using separate chaining, which means he finds his hash key, and then he checks to see if the person is there, and if they are, he returns that person. So he returns HTH of I. If he finds the person, he returns a pointer to that person. If he doesn't, he falls out of the for loop and comes down to here. The person isn't in the hash table and it should be added. He creates a new person object. Then notice, instead of using a dot, he uses an arrow. So this is another way to dereference a pointer when it is a pointer to an object. You could write it like this, star P dot name, but please don't do that, it's ugly. They introduced the arrow notation to make it a little easier to get access to the field. So when you have a pointer to an object and you want to access its field, use the arrow operator. So we assign name to name, neutral to mood, and null indicates a pointer that points to no variable. Remember, we say that a pointer variable can point to a variable, but when we assign it null, it points to no variable. Points to no variable. In practice, null is actually equal to 0 most of the time. Null is defined for you. It's a constant. Then we push back the pointer and we return the pointer. And notice if we do not find the person and add is false, we return null to indicate that we did not find the person. Okay, so I'm just going to take another 2 minutes. Here's the code for adding a person. We first try to get the name of the person through getLine. Then we try to find the person, saying false, add is false. So if the person is not in the table, if the person is already in the table, we don't add them again. It's just like if you try to choose a login name that is already taken, you don't get to take the other person's login name. They tell you it's taken. You need to choose a new one. If it's not taken, then we insert the person by giving true, and now it's in the table. Let's say we want to add a person in a relationship. So let's say we want to create a relationship between Rhett and, say we want to create a relationship between Rhett and Scarlett. So if it's in relationship, we first read the two names. Then we try to get pointers to the two people. If either of the people is not found, we print unsuccessful. Otherwise, in this case, P is the pointer to Rhett and P2 is the pointer to Scarlett. So we set P's in relationship to be equal to P2. So now the in relationship pointer points to P2. Okay? So that's how we make pointers point to other objects. In your lab, which the first part is due on Friday night essentially, you will need to store pointers to bitmap objects. This is how you can do it. You will be using the arrow operator to get access to that field. You will be able to create new bit maps by saying new, in this case, I think it's a bit matrix. Second, right there. So you can say new and the name of the class to create a new object of that class. So in lab, you'll create new bit matrices. You simply say new and the name of the class, and that will give you a new object of that type. Instead of using dot to get access to the field names, you will use an arrow. Okay? You won't have to do a whole lot with pointers for this first part of the lab. You'll have to do more work with pointers next week. But also on Tuesday, we'll be continuing to talk a little bit about pointers as we get into lists, iterators, and bad vector usage. Okay, so there you have it. If you have questions, either make sure